Welcome everyone. I think we'll get started. My name's Todd Lookingbill, and I'll hand it over to one of my colleagues, Rob Anderejewski, in a second. And if you're in this session, you should be in the Gambles Mill Eco Corridor, here to hear about the restoration project that we're doing within the Gambles Mill Eco Corridor. So let me get my screen shared, and I may mute myself. Rob, if you want to take over.
All right, thank you, Todd. So I want to welcome everybody to our session on the Gambles Mill Eco Corridor. My name is Rob Anderejewski. I'm the Director of Sustainability at the University of Richmond. And the University of Richmond is the host site for this project. Before getting started, we'd love to know who's in the virtual room today. So if you can, in the chat, just share maybe what organization you're with and where you're coming from today. We're just excited to know about that and can tailor some of what we share based on some of that information. This is a story about a 13-acre project that grew from a conversation about how to refurbish a trail. And ultimately, the key to this project is this idea of collaboration. So in just a second, I'm just going to ask each of the people who will be presenting today. We're doing this collectively with 5 of us to just introduce themselves. Like I said, I'm Rob Anderejewski, and Todd, I'm going to kick it over to you next.
Great. So I'm Todd Lookingbill. I'm a professor of landscape ecology in the geography department at the University of Richmond.
Good afternoon, everyone. I'm Jill Nolt. I'm a landscape architect with Water Street Studio in Richmond, Virginia.
If I can find the mute button there. I'm Bob Siegfried with RAS. We're a design build environmental restoration company, and I'm headquarters out of Richmond, Virginia.
And hey, I'm Jennifer Hatchett. I am representing the City of Richmond Department of Public Utilities today.
Great, thanks. And like I said, this is really a story of collaboration as much as it is about changing our landscape and our stream. And so really to understand about the Gambles Mill Eco Corridor, it's great to get a little bit of history. And Todd and his classes have been working in this area for many years. So I'm going to turn it over to him to tell a little bit of the story about the site background and history.
Thanks, Rob. So I'm a geographer, and so it's my role to give a quick orientation to the place, starting with this bottom image. We're working our way back upstream from the right to the left, beginning at the mouth of the Chesapeake Bay, and working our way backwards along the James River, from the Chesapeake Bay along the James River to the city of Richmond, which we've heard a lot about throughout the meeting this week. And then if you keep working your way further upstream past the big buildings in the city, you'll see the kind of western boundary of the city is where the University of Richmond campus sits, with a lake prominently featured, and the outflow from that lake that carries water through the Little West Dam Creek into the James River and eventually out to the Chesapeake Bay. We zoom in on that area around the Little West Dam Creek. This is the watershed of the Little West Dam Creek. The brown is the University of Richmond campus again, right on the edge. If you see the dotted line, that's the city boundary. So we're right on the western edge of the city. You can see above the university, there's significant contributions to this watershed from neighborhoods that lie above and to the east of campus. There's also in pink a golf course that kind of is part of this story as well. This box in red is what we refer to as the Gambles Mill Eco Corridor, and that's the focus of this project. So if we zoom into that, we can see a trail that runs about a half mile in length along the golf course. On one side is the golf course, and the other side is the university campus. And right along that trail is the Little West Dam Creek, which will be the focus of this study. And about half of that half-mile linear length has been restored as part of that project. So we have a roughly 13.5 acre area of land included within this restoration project, which will be the focus of what we talk about today. The earliest mention of this property is as a land grant from Governor Nicholson to Giles Webb in the early 1700s. And Beverly Randolph then owned the property, which would become part of the thriving town of Westham. And in fact, Westham kind of rivaled Richmond for a while as a trade center. Peter Jefferson even bought a bunch of lots in this town himself, and Thomas Jefferson writes about his father surveying and recording some of this property. And then in the pre-Civil War era in the mid-1800s, Benjamin Washington Greene came along and purchased the land and operated it as a plantation, including the enslavement of 15 adults and children, a history which the university is still reckoning with. So at that time, there was an active sawmill on the property, which Bob will touch on a little bit later. And it's likely that that mill was operated by the Gamble family, which is why the road which runs parallel to the creek was known as the Gamble's Mill Road. And eventually, we've adopted the name for the entire parcel. In 1914, Richmond College moved from its more downtown location here, and we've been in this area ever since. A rail line bringing coal to the university, and the road itself, which was described as a terror and a horror due to the number of accidents on it, was closed to automobiles in 1990. But this area continued to play a significant role in walking and biking transportation for the city. Here's the corridor in the box in blue that just zoomed in, which is at the right edge of a major bike route outlined in green on the map, proposed for the west end in the city's 2000 transportation plan. And then on the right, scaling back to the entire city, we can see how the corridor fits in with a couple of main regional bike routes. And so this is the corridor area that we're talking about right now. So our focus for the past 10 years or so have been on the trail. And as one example, we had a local community member inspiring us to think creatively about the potential for this trail to be restored and to catch some of the runoff from the neighboring golf course before it entered the creek. Similar ideas were kicked around, and we even wrote a few proposals with the local community, but the funding never materialized. At the same time, the university was recognizing the potential for this space as a recreational greenway in its campus master plan. So again, to orient you, it's this big green area in the lower right of the map that we're focused on. This is what the areas looked like, or had looked like at the time. Basically a washed out old road shown in the top left, invasive plants running rampant, covering everything. Multiple tributaries coming across the trail, some of which were piped, some causing periodic flooding of the trail. And then in the bottom right, a deep, wide stream banks within the creek itself. Nevertheless, the distance didn't stop us from using this area for our teaching mission. Especially biology classes use this area, and as an example of what you might find in an urban impaired stream. So we had biology classes kind of making frequent use of this site, getting down, getting our feet wet. And the other major user on campus were geography classes. So in geography classes, we would map the features of the site within the regional context, compare the sense of place fostered in this area relative to other areas on campus. And the area even featured prominently over the years in the Earth Lodge, which is one of our co-curricular communities for students on campus. And we've had scattered student volunteer opportunities associated with that. I love this picture in the bottom right because it shows my son helping out with some trail maintenance, and he's now about as tall as I am. So that gives you a sense for how long we've been kind of working down in this area. But it was quite honestly a small handful of us, and it felt like there was an opportunity to engage more faculty and more students in more varied disciplines in this little corner of our world to make it a true living lab for our campus community.
So the next piece of this puzzle is really the opportunity to have the university's eyes opened by people who had a more objective perspective on the Gamble's Mill Eco Corridor than we did. I think Todd did a beautiful job representing how it was utilized, but we weren't really seeing its potential until a discussion with landscape architecture firm Water Street about the trail restoration turned into something much, much bigger. And Jill Nolt's going to tell that story.
Thanks, Rob. Yeah, so this part of the story, goes something like this, that we got a phone call from the university architect. They had secured a small amount of funds to do trail improvements. There were some safety concerns as this trail of about a half mile connected the campus to a little retail area. It was used informally by the community, and it had been targeted for a long time for some upgrades and some trail improvements. But walking the trail with them, we knew that that was a limited approach to just do a trail improvement. We saw the 7 outfalls that were pushing water onto the trail. There were always parts that were wet and overgrown. And we knew there was an opportunity here for this to be more than a trail cleanup or a beautification project. And several of the sessions today have really talked about partnerships and strategic partnerships. And this is another great example of the successes of that. We had done some past collaboration with RES, and we knew there was an opportunity here to expand this project to include a stream restoration that really started to make it a community and a public project to go above and beyond the initial goals for a trail cleanup. So I'm going to hand it to Bob to just talk a little bit about RES and what they do and what they offer.
Yeah, thank you, Jill. Yeah, so the stream, to put it in context, it's in a 3.5 square mile watershed. It's been populated since the 1700s. So as you can imagine, the stream has seen a lot of stressors and damage on it. High eroding stream banks, lots of invasive species. We know it has a history of being dammed for water power, and anytime you dam a stream, you end up with sediment accumulation, the floodplain accretes, and you end up with a stream that's has really poor habitat for stream fish and other animals that would live in a healthy stream ecosystem. What RES, our sort of niche in this world is to look for streams, property owners like the university who have streams like this. And then we look for localities or other people, who, state agencies who might have a permit that requires them to address issues like stream degradation. And in this case, we were already working with the city of Richmond, who has the MS4 permit that requires them to reduce the amount of sediment and phosphorus and nutrients that come out of the city towards the James River and eventually towards the Chesapeake Bay. So we were able to realize that this was a good candidate for restoration. We could reduce nutrient loads, and we could put these two people with a need, one with property and a need for a trail and improvements, in a city that had a requirement under a permit to do that same type of work. So I want to turn it over to Jennifer, who can give us the city perspective.
Okay, yeah, thanks, Bob. And looks like we have a really diverse crowd here, so that's exciting. So again, my name is Jennifer Hatchett, and during the brainstorming of this project, of this eco corridor, I was the Deputy Director of Public Utilities at the City of Richmond, where I led the stormwater, combined sewer, and sanitary sewer departments. So, but if you notice, you read my bio, today I now work for RES. So such a successful project that I joined the RES team. Mm-hmm. But, Rob talked about, or Todd talked about the university's master plan. And at the same time that was going on, the City of Richmond Department of Public Utilities was working on our own efforts to meet multiple permit requirements from the Virginia Department of Environmental Quality, as well as the EPA. So at that time, I was managing 3 different permits. So we had a wastewater treatment plant permit, we had a combined sewer permit, and we had a separate stormwater permit for the MS4. And just to give you all some perspective who are not from the city, 1/3 of the city is a combined sewer system, and the other 2/3 is a separate system. So we were working with 3 different permits, but with the ultimate goal, right, of improving water quality. So we had this idea that kind of culminated in 2014, that why can't we have one permit, right? Like, why can't we just kind of manage this discharge into the city waterways in a more holistic and economical way? And so we decided to head out on this RVA H2O collaboration plan that we created, and we went after the first integrated permit in the state. So after 3 years, we created the stakeholder group. University was part of it. Res was a part of it. We had a lot of different stakeholders, and we created the RVA H2O Clean Water Plan. And in that plan, I should say at the same time, we also received our integrated permit. So we were really excited about that. So we created this 2017 RVA Clean Water Plan, which is the roadmap that the city is still following to get to what we call cleaner water faster. Right, so within the plan, we have 10 strategies to achieve the goals of the permit, but also to achieve the goals of the stakeholders, because we worked with a lot of NGOs and private companies in the community to come up with these strategies, because we knew we couldn't do it alone. The city owns just so much, property, that a lot of this was going to have to be done on private property and with our partners. So you can read through the 10 different strategies that are in the plan, and these are annual goals. So if we were to look at green infrastructure within the MS4, so we want to install 104 acres annually, or to plant native plants, and tree canopies is another big thing. And we had multiple benefits here too. We also worked with the Science Museum of Virginia, and have shown that by increasing trees, you reduce the heat pockets within the city, as well as if you increase water, you do the same thing. So it was really a really interesting project or process to go through with all of these different stakeholders. So then when we were approached, Bob mentioned that, we had been working together. We've been working with Res. We had U of R, University of Richmond, as one of our stakeholders, and came to us and said, hey, we've got this great stream restoration project, and it fits into some of your key strategies of the Clean Water Plan. And so it just became this win-win type project for a lot of different stakeholders. And so always one of our goals of the Clean Water Plan was finding ways to work together. So often in government agencies, private agencies, even in the communities, you work in silos, right? So I might have a project that I want to do for DPU, whereas Public Works is going to do their own project by widening the streets, which is adjacent to a park, which is Parks and Rec. And then we might have an NGO that wants to do something similar. So what we decided to do was start mapping these different needs and these different wants, and bringing it all together into one project if we could, which was going to save us, money, right? So the economics, but also allows us to do more projects in a thoughtful process. And so for the city and for the university and for its partners, Res and Water Street, this worked out perfectly for us. The university had a need and desire that fit in with the goals of the Clean Water Plan, and Res and Water Street Studio helped pull all of these stakeholders together to implement it's not just a project. To me, it's more like a program, because we have so many different features out there, not just for the university or the city, but also for the community.
So we had all of the key players established at this point, and I would recommend to everyone hearing this today to really check out RVA H2O. To be part of an integrated water management plan was a privilege. It was fascinating. It was a little bit messy, but so many stakeholders were involved, so many different voices, and for the city to put that together was really incredible. So we now had a landscape architect and engineering and ecological services firm, the city and the university ready to move. But we really recognized that we wanted this to be an inclusive project. We wanted to make sure we engaged our community. And unlike some stream restoration projects that might happen in a more rural setting, we're on a campus. It was very, very visible. And we also had the opportunity to align what was going on with our educational mission. The idea of a living learning lab was really important and had been for years, and we wanted to continue to involve our faculty and students in what we were doing, as well as the surrounding community members. And we were very fortunate, again, to have the expertise of Water Street Studios, who have done design charrettes, as well as Res, who have worked with lots of local communities on restorations. And so Jill's going to share the story of some of our community engagement processes that really got the voices of the people at the front, so we could design collaboratively.
Yeah, we knew from the start that we needed to not only bring these stakeholders together and have a common goal and vision for this project, but we needed to engage the community at a level where there could be support and consensus and a shared vision. So we started with a charrette, a kind of workshop where we were communicating ideas and dreams of what this area could become. I think the obvious starting point was the educational component of engaging students in what kind of research or classroom or projects could happen along the stream corridor or by using the trail in this natural environment. But we also needed to include the administration and the faculty at the university to make sure that this project was meeting the vision that was in their master plan. We connected quite a bit with the golf club stakeholders, the golf course stakeholders, and the neighboring communities. And so we had a series of meetings that were informational, that were looking for input and advice and suggestions. Next slide, Todd. And as the design progressed, we continued to go back to those groups and share the progress on the design and the defined goals for the project. Next slide, Todd. We knew the project needed to tie into some of these network connections that Todd mentioned earlier in the project. The half-mile trail we knew could tie into the pedestrian network of the university campus, but there was also a real opportunity to connect to the pedestrian and the bicycle networks that took you page right down to the James River and up into the surrounding neighborhood. So that was a priority, that this project could complete some of those larger master plan goals. Next slide. We used a lot of mapping to communicate things that were not highly visible. You saw from those early images, the site was very overgrown with invasive vines and other plants. It was hard to really understand the extent and the scale of what we were working with. We knew from a trail standpoint, it needed to be safe. It needed to meet ADA accessibility guidelines. So we were able to do some mapping that corresponded with the charrettes and the meetings to help communicate some of the ideas that were being presented. Next slide. We knew the stream restoration was going to have an impact on the wooded area. There are two wetland areas that we knew we needed to preserve, that we needed to make sure that we were protecting those from a permitting standpoint. And we wanted to keep as much of the native wooded area as we could, but we knew there was going to need to be an area reserved for the stream restoration. So again, starting to map these, helped in communicating and sharing ideas among all these stakeholders. And then the next slide communicates this kind of idea that kept resonating through these meetings about both cultural and natural resources. I mean, the main purpose of the trail is to bring people to this very special natural place. And so we were always building upon discussions of how we engage people with the place. And beyond people, we knew that there was an opportunity here to enhance the native flora and fauna as we do this project. Next slide. So there was a lot of dreaming that happened, you know, program ideas of outdoor expansion of the gardens, or how we could use the old ruins from the water treatment plant for an outdoor classroom, all at the same time keeping in mind of, you know, how we could invite our insects and our wildlife to be part of this new habitat. So, you know, dreams of pollinator gardens and woodland walks all became part of these conversations. And so many of these got implemented, and some are still some long range goals. Wetland research, boardwalks, and outdoor gathering spaces for classrooms are all part of these visions. But what came out of all these charrettes and community engagement meetings was a master plan. Within that, and at the core of that, are 4 priorities for the project. First was the invasive species management. And then a big driver in all of this is the stream restoration. The stormwater management, we mentioned the storm outfalls coming from the east side of the project. And then the community in connectivity, the trail itself, and what impact it can have to bring people to this new place.
All right. So one of Rez's first jobs, and you know, after assessing the stream, is to address the invasive species. We could roll to the next slide. The first thing you noticed as you walked up to this wooded corridor along the stream is that you couldn't see into it. You couldn't see the stream. There's actually buildings in there you couldn't see. The understory is invasive privet and other invasive shrubs that was suppressing the native shrubs and the native ground covers, the wildflowers and native grasses. But up in the canopy, you can see the vines, the English ivy and the porcelain berry crawling up those trees. And you can even see, even in this picture, that this should be a fairly shaded, wooded area, but you can see a little light coming through. That's because the canopy was being really depressed by the impact of these invasive vines, reducing the vigor and health of these trees. Many of them were suffering from diseases associated with being so heavily infested. So Rez brought in our crack invasive species troops. Next slide. Goat busters. So these guys came in 100 goats strong and spent several weeks on the property chewing down all that invasive material you saw, the shrubs, the vines, the other material that was in the floodplain. And this does several things. It allows us to then go in and do mechanical and chemical controls in a smaller, more limited way, because they've done the bulk of the work. They're also just, it's surprising, their hooves, it's like putting cattle back on grasslands. You actually see a response of the native species to having herbivores do the work as opposed to humans. So Rob, I think you wanted to jump in at this point.
I did. Thanks, Bob. I just want to recognize that the university was hesitant to bring goats here. And this was one of the cases where a partnership can open your eyes to possibilities. And Rez pushed and said, no, we really think this is a good idea. We've done it elsewhere. We were just concerned about the combination of electric fences and bad choices. And so we had a lot of conversation, but ultimately it was an incredibly positive decision the goats became the story of the eco corridor. Long before we brought in any equipment to restore the stream, the people were interested in the project. They came to watch the goats at work. They followed them as the fences got moved. They penned the goats to different areas, and they just did a phenomenal job. They really cleared out an area. And in the next photo, you can see after planting, just an entirely different dynamic. That the trees are on the far end of the stream now. You can absolutely see all the way across. And it wasn't just goats. We were able to do education on why invasive species were important, and then talk about also mechanical removal using powered equipment and chemical spot treatment after the goats and the chemical equipment came through. So we had a tripartite invasive species removal program that folks that probably wouldn't otherwise have been interested were very interested. And then it allowed us to really start talking about what's a stream restoration and why is the waterway that they're looking at in need of improvement. And so the next phase from invasive species was the biggest part of this project, was the stream restoration itself. And prior to bringing in the equipment and changing the channel and improving the nutrient loading that was going to the James, it was really important to us, and with Todd's influence and other educators' influences, to bring our students into this. We've used the site for decades in biology, and this was just a really great opportunity to allow our students to do some pre-treatment water monitoring. They could look at the nutrient loads, look at the sediment, look at different levels of water quality, do a benthic assessment, and that allowed us to have pre-treatment data, which we could then compare with post-treatment information later on to look at the effects of the stream. And so it was really exciting. The goats were the impetus for a lot of exciting movement and had a lot of people really interested. So by the time we had the equipment come in, people were charged. One thing that we also learned from RES was how important it was to communicate with the local community about changes to the landscape that they would see, especially when it comes to tree cover. And so I'm going to hand it back to Bob to talk about how we did that.
Yeah, in all our stream restoration projects, these are significantly sized construction projects that require, as I always say, big yellow equipment. This is not, we can't undo 200 or in this case 1700. So we're talking 300 years of mismanagement of this resource with buckets and shovels. So we try to set that expectation. One of them is that you were going to take down trees in order to allow the equipment to get in there and rework the floodplain and the stream to make the stream healthier. One of the things we went through when we surveyed all the trees in the corridor, all the larger trees, but we also assessed their health. As I mentioned, a lot of them were very sick. They were covered in invasives, and many of them close to the stream were undercut by erosion and either were already falling in or would eventually fall in as the stream continued to erode. And so on this graphic, you can see the trees of circles. The red ones are the ones that are in very poor condition. And you can see that most of them that are along the stream are in that very poor condition, the red circles versus the green circles. So it kind of helped the public understand that the trees that are there are not healthy and wouldn't stay around for very long. In the next few decades, we would see a real reduction in the further reduction in the health of that riparian corridor. And what we want to do is give the stream a healthy reset, but also give the riparian buffer a healthy sort of ecological reset. Next slide. So we went from sort of this, where you've got high banks, 5 feet tall, typically. In some cases, we were up against the valley wall and it was much taller eroding banks than that. And no access to a floodplain, which is a big concern with a stream like this. It's flashy. We're in an urban situation. Anytime it rains, we got a lot of flow in that channel, but it can't get out of this 5 foot deep channel. So what we did, next photo, is give it a new active floodplain with the stream banks that are about a foot tall. And so now we have a place for all that flashy urban floodwater to go out into this 40 to 60 foot wide floodplain and not contained down inside the much smaller stream channel. We have a great base flow, as you can see here, that's coming out of that 3 mile watershed. But we were this newly excavated, we removed all the sediment that collected behind the old gristmill dam. And brought that down to create this new floodplain. And you can see the trees we kept on either side. But next slide. And you can see the meandering pattern we gave to the stream. That's a way of managing some of the energy in the stream. Inside each curve, there's a pool for habitat, and in each straightaway section between each curve, there's a riffle. So we produced habitat inside the stream. The meandering pattern helps the stream control its velocity. And then that width of the floodplain helps us manage those storms that we get in urban situations. Next slide. Where we are looking down from the valley wall along the length of the floodplain, you can actually see the wastewater treatment plant. That's an early 1900 era wastewater treatment plant. So not only did we dam this project up at one time, we were also dumping our waste products right into it. And so it obviously has seen a lot of stress and mismanagement over the years. You notice we've got some large stumps we salvaged from what we cut down, and we've integrated those along the floodplain as sort of speed bumps during high flows, but also there's wood inside this channel itself for habitat improvements. Next slide. We have 4 major tributaries that come into the stream, bringing additional water in from the golf course side of the project. And those channels originally were deeply incised and cutting down and eroding. In several cases, we provided new openings so that the waters would come through. Instead of concentrating through a pipe and blowing out like a fire hose, we gave this particular crossing a whole new opening. And the structures you see in the front there cascade the water down. These are step pools, and they're very suitable to managing the energy that comes down the stream. It's steeper than the main channel. So instead of making it migrate left and right, we actually make it move vertically up and down over the step and into the pools. And that helps reduce that velocity. Next slide. There you get a picture of the step pools, and you'll notice some sediment accumulating in that pool. So we've converted these stream reaches, these trips, from eroding and pushing sediment downstream towards the James and towards the Chesapeake Bay. We've converted them into storage areas where this material is captured and retained on the floodplain. And that's one of the great functions of a floodplain, is to capture that material and keep it from moving downstream. Next slide. And all along throughout the floodplain corridor, we planted over 25,000 trees and shrubs. We seeded with over 200 pounds of native seeds, and we have pollinator areas that we seeded, upland areas, floodplain wetland areas, so different types of habitat and different types of plants and seeds. We even used a local nursery that collects local seed from the James River Park system, grows them up into plants and plugs, and we use those as well to ensure that we're also getting some of that local genetic diversity into the project. Next slide. But I think one of the most exciting outcomes of this project is look at what we did for restoring the fish community. In the before condition, before restoration, the fish in the creek were dominated by species that like ponds, like bass and bluegill. The stream didn't have a lot of riffles. It was mostly large, scoured out pools and a lot of poor habitat. After restoration, we have about 50% riffles and then 50% smaller pools. And this really is the type of habitat stream fish prefer, including several kinds of minnows that were not there in the before condition. In fact, after we shocked it this last season, we found fish that are characteristic of the James River, including some catfish and gizzard shad that we know had to move up from the James River into this reach, finding this new habitat that they could inhabit. And I think it really speaks to turning back that clock, historical clock, to what maybe the stream was like, prior to damming back in the 18 and 1700s. So I'm going to turn it over to Jill. I guess, Rob.
Thanks, Bob. So this stream restoration was really exciting, and we had to turn our attention to the third phase after invasives and the stream restoration was stormwater management. And a lot of the way this kicked off was a lot of problems with the trail itself having to do with bad stormwater management in the past. And Bob already mentioned step pools and daylighting, which were really important features. But one thing that we wanted to do was highlight best management practices when it came to stormwater management, because not everybody would understand what was going on in the stream. But as they walked the trail, we wanted them to be able to see things that they could bring to their own lives and their own businesses. And so things like the step pools were really visible. So we had signage there, as well as rain gardens and things like that. So stormwater management was the next on the list.
Thanks, Rob. So the next slide shows a couple of images of these before conditions where the trail was constantly flooded with water. As Bob said, 4 of those were tributaries to the stream. So as part of the stream restoration, we were able to find solutions like the step pools to help direct that water and safely get it down to the stream. However, there were a handful of areas where the outfalls were from storm pipes. And so we made a strategic decision in an area where there were 2 storm outfalls to actually relocate the trail in an effort to make a rain garden, make a substantial area that we could collect this storm water, allow it to infiltrate through a soil medium, improve the quality of that water before it goes into the water table, or during a big storm event to then surface flow towards the stream. And so the next slide shows the result of that. There were 2 locations where we deliberately realigned the trail to give opportunity, give some more space to these storm outfalls and really make an educational component. So this is the rain garden last spring, shortly after it was planted, and it will look even more lush this summer as well. And then last but not least is that trail reconstruction that started this whole project. Next slide shows that condition, the kind of broken old service drive running next to the power lines, next to the golf course, really forgotten, but still used. And so by way of focusing on the trail as we made our way out of the project, we installed over 100 nursery specimen trees, I think over 500 shrubs and thousands of perennials and native grasses. We worked with some of the local nurseries and with Tree Lab, which is a nonprofit greenhouse that's associated with the city of Richmond, providing trees and shrubs to the city. So we found another strategic partnership in our source of plants. Next slide just shows some of those specimen plants, the variety that we were able to achieve through the planting along the trail and in the stream corridor. And the result is a trail that has been improved, native plantings. We were able to do an expanded community garden, 2 outdoor classrooms. The wetlands still exist and are protected. There's a pollinator garden walk. There's a woodland walk. And in those locations where the trail crosses the tributary, we did these open culverts to allow that water to flow, in this case, directly into the wetland. and have a safe trail crossing. The result has been really surprising in how popular this has become as a destination, not just for the university community, but for the larger community surrounding this. And the views and the engagement to the stream restoration and to the stormwater management projects just enhances that quality of being in nature and moving through this project.
Yeah, so that brings us to the present day. The official ribbon cutting ceremony for the trail was scheduled for Earth Day 2020, so almost exactly a year ago. Obviously, that didn't happen with the pandemic that occurred right during that time frame as well. But in other ways, the timing of the completion of the project couldn't have been better to encourage outdoor activity engagement when it was needed, really needed most. So we continue to have classes in the stream and along the uplands and the riparian corridor. We have students helping with this continued monitoring and plan to do that for many years to come. The classrooms that Jill just kind of mentioned and were probably one of the features most requested in those charrettes kind of early on. They've been heavily used, especially during the pandemic, when faculty literally wanted the extra breathing room and to get outside. So because the project has so many financial, environmental, recreational, spiritual elements to it, these classes are much broader than they were before. So there are disciplines ranging from economics and business management to English, biology, and sociology, all engaging in this space. It's super exciting. We've also had classes camp down there, use the space to demonstrate things like drone technology. And we're continuing to, in fact, these drones are one of the tools that we're using to continue monitoring the area. And a number of student labs and research projects have already made use of these data. And right there, as we turn, we can actually see the remnants of that dam that Bob's talked about a couple of times. Back on the ground, we have tagged all the trees. We're almost done tagging all the trees. We kind of have research going on, tree inventories, monitoring. We have education and outreach on some of those signs. We have phenology studies where citizen science can go on. People can go put their camera on top of this little post, take a picture of the space, send it, and we're capturing those pictures from that same place over time to see how this place changes. We have continuing monitoring of wildlife as well with camera traps, pitfall traps, acoustic monitoring stations. We found some interesting non-human users, including this piebald fox that frequents the corridor. Pretty cool catch up in one of our cameras. And there are signs everywhere that point to the step pools, the pollinator meadow, the overall goals of the restoration. So getting some great education to the public as they kind of use this resource. And then returning to my personal perspective as a faculty stakeholder, many of these signs have been designed by students. And you know what they say about how teaching is to learn twice. Our students have really embraced that. They're going into this area. They're really just enjoying not just recreating, but learning about the ecology, the hydrology, the history of the space, and eventually even participating in the unique storytelling through sign development and so forth. It's been a lot of fun.
So that's where we are today. A healthy stream sending less phosphorus, nitrogen down to the James River and the Chesapeake Bay. An engaged community full of trail users, lots of families on the trail, even a little free library is there. A newly refurbished community garden with more student gardeners than ever before. Students using the site as a living laboratory, faculty using it for research. Native species in abundance, more than 25,000 trees, shrubs, and grasses planted. And this is just a story of the triple bottom line of sustainability with environmental benefits, social benefits, and just a financial arrangement that allowed the university to move forward with much bigger than a trail project through partnerships that benefited the city, benefited Res and Water Street, and certainly continue to benefit the University of Richmond and the local Richmond community. So thank you for listening to our story of collaboration, and we invite your questions or your insights now.
This is Jennifer Wamper. That was excellent. And I just want to thank you all for this corridor because it is one of my favorite bike rides from Carytown down to the James River Park system. And I just wonder if you all have thought about capturing data, or maybe you've already captured it, in terms of how many students are choosing to take this corridor when they go over to the shopping center on River Road or when they go to the James River Park system, and how that impacts air quality and, you know, decreases carbon emissions.
We don't have exact data yet, Jennifer. We are working. There's a faculty member who is interested in doing trail user assessments, and we've done a little bit of that, just general counting, but it's a really, really good question. One of the things we didn't mention that was a very positive benefit is the River Road side is part of the county of Henrico, and they created a sidewalk that we'd wanted for years, that where this trail ends, there were so much more users, many more users, they wanted to connect it with the other entrance to campus, a road. So that has been a huge win for us, and relates back to the loop that Jill was talking about. So I really love this suggestion, and I'm thinking post-pandemic, we are, when we are able to get more outside and be more together, we're going to see more research related to what you're talking about there. It's a great research question.
In terms of trail use, we've seen, so we have some students counting, and we see about 50 users, 50 people per hour. Some of the studies, some of the kind of counts that they've done so far. We have some air quality stuff going on, but as well to kind of track those indicators, but that's kind of early on. Mussels, yes, we need to get mussels in there. I thought about that during that presentation on Tuesday. It would be great to get mussels into this environment. You're muted, James, if you're talking.
Yes, Paul Bukovics had a grad student that looked at reestablishment of mussels in Richmond urban streams, and there wasn't a lot of promising news to tell about that. But looking at what you've done to this stream corridor, it would be really interesting. It would have actually been really interesting to compare the outcome, actually. That's a fairly recent study. And the flashiness was basically, one of the big problems there with being able to maintain mussels in the system. So looks like, that's been a big focus, is reducing the flashiness. And so maybe this would be good mussel habitat. And then with Harrison Lake just down the road, I mean, you couldn't be a better primed spot or source for getting the appropriate critters. So that would be a fun project.
For sure. Maybe we could get the mussels in the lake too, as a little mini hatchery in our lake, and then move them into, I don't know, just dreaming big.
They do have them in their hatchery pens.
Yeah, you do have, I think you do have some type of mussel in the lake, because we find the dead shells downstream. It's occasionally, but they're pond species, not stream species. So, but we just recently put stream gauges on the site with time-lapse cameras. So we're going to be able to really fine-tune our understanding of the flashiness of the system and how often the system gets up into the floodplain. But just some past work, we know if we get somewhere between 1/4 inch and 1/2 inch of rain, we've got water all the way across the floodplain, which is great because that's where we want it, not down in a channel that's going to fall apart from erosion.
And to follow up on that question about the availability of the wildlife cameras. Yeah, so we have a professor, Dr. Seven, who's working with the Smithsonian in their kind of larger project to kind of, and is contributing the images to their database, and they're going to be uploaded and online and publicly available for sure.
No, that's great. That's a great program.
Yeah, I think one of the things, people focus on stream restoration and they think just about looking inside the banks of the stream, right? But a stream is really the whole thing. It's the floodplain, it's the riparian buffer, it's the whole corridor. And what we see with lots of stream restorations is that we're creating habitats that weren't there before, whether it's a lush floodplain, whether it's amphibian breeding pools in the floodplain, pollinator habitat. And yours, I mean, I'm really glad to see the professors looking at the birds and the amphibians and the rodents and everything, not just what's swimming around in the stream, because the focus in the past and most research has been what's in the stream. And I think there's so many ancillary benefits, especially in urban corridors where we don't really have a lot of amphibian habitat or pollinator habitat or early successional habitats that really support this diversity of species. And what animals did live there now have better, like the fox, now have better hunting grounds. So I think there's all kinds of ecological spin-offs. We lose some mature forest, but that was already degraded, but we gain back a multitude of other ecological habitats and benefits.
There was another question in the chat by Corita, who had to step away, about wondering if there's a water if there's a water resources aspect to the plan with the university in particular. And yeah, I'll defer to Rob a little bit on that, but I think in some sense this is helping to motivate the university. This is definitely getting the pressuring, I would say, the university to think more holistically and strategically about our water management plan. I don't know, Rob, what your perspective is on that.
No, I agree wholeheartedly. Not just about our water management plan, but our understanding related to what Bob was saying. We have West Hampton Lake is at the center of our campus, and it's really about the water that flows into the lake and the communities above it in the watershed. And this project is helping people understand watersheds in a way that the lake never has. And so it's been really interesting that if we're going to restore our water quality of the lake, we have to really do community connections and build relationships and change the land upstream, which is a bigger issue, but it's more holistic and will help solve for longer term issues. And so those conversations are beginning to happen, but they're not as easy as a technological fix. There's people involved and landowners and local community members.
So I think that brings us right up to our window cap, right, Angie? I want to remind everybody that the silent auction closes at 3:45, so you have time to get in a final bid if you're inclined to get a new kayak or a new mug, and everything from the small to the large. And then at 3:50, there's in the James River Room, there's a closing plenary by Richard Smartin on revitalizing urban waterway communities, streams of environmental justice. So there'll also be river trivia and prizes for that. Angie, am I missing anything?
No, that seems like everything. I would just want to thank all of our presenters again today for this great presentation. So thank you. And thanks for everyone for joining us. And yeah, we'll have a little bit of time for a break and then see you in the James River Room. So thanks again, everyone.
Thanks all.
Thank
Take
you.
care.
Thanks.